Analyze the chemical structures and molecular weights of the given compounds. Butanol, C4H8O, 72.10 grams per mole, and aldehyde containing a polar carbonyl, C=O group. The hydrogen atoms are only bonded to carbon atoms. There are no O, H, N, H, or F, H bonds. Pentane, C5H12, 72.15 grams per mole, a nonpolar hydrocarbon containing only carbon-carbon and carbon-hydrogen single bonds. Propanoic acid, C3H6O2, 74.08 grams per mole. A carboxylic acid containing both a carbonyl, C=O group, and a hydroxyl, OH group, which features a hydrogen atom covalently bonded directly to a highly electronegative oxygen atom. Note asterisk, all three compounds have extremely similar molar masses, sim 72 to 74 grams per mole. This means their London dispersion forces, LDFs, which depend on electron cloud size and polarizability, are highly comparable. This allows us to focus almost entirely on differences in their primary polar intermolecular forces, IMFs. Identify the types of intermolecular forces, IMFs, present in each compound. Pentane, because it is nonpolar, it exhibits only weak London dispersion forces, LDFs. Butanol, because it has a polar carbonyl group, it exhibits both LDFs and dipole-dipole interactions. However, it cannot form intermolecular hydrogen bonds because it does not have a hydrogen atom bonded directly to a highly electronegative atom, N, O, or F. Propanoic acid, because it has an hydroxy group, its molecules can engage in highly stable intermolecular hydrogen bonding in addition to exhibiting dipole-dipole interactions and LDFs. Relate intermolecular forces to boiling points. The boiling point of a molecular liquid is a measure of the thermal energy required to overcome the attractive intermolecular forces holding the molecules together in the liquid phase. Stronger IMFs require more thermal energy to break, resulting in a higher boiling point. Hydrogen bonding is the strongest type of polar intermolecular attraction among these substances. Since propanoic acid can form these strong intermolecular hydrogen bonds, it will have the strongest overall cohesive forces and therefore the highest boiling point. Combine the findings to select the correct option. Propanoic acid has the highest boiling point because it is the only compound among the three that can form intermolecular hydrogen bonds. This corresponds to option D. The correct answer is option D, propanoic acid, because it can form intermolecular hydrogen bonds.